Session for this afternoon. We've had two really good sessions, and I'm sure the next session is going to be just as good, or maybe even better. 'Cause Dale is with Shively, and I got to know him back when we put the Big Master, or Jim Coleman did. I didn't put the Big Master antenna up down in Montgomery on the 1200 footer, and what he said about all the stuff inside the tower. There's all kind of hybrids and dummy loads and splitters, and he said that you couldn't have a fat tower guy to go up to work on the tower light because you would never get by. There's a lot of stuff up there. Now you can't go up it anymore. But Dale's with Shively, manufacturer of antennas and transmission lines, and they do all kind of master antennas. I think the one is that no, that one down at Wilcox Road. That's what kind of panel? But there's a lot of Shively antennas, single frequency and multiple frequency antennas around. They do a really nice job. So Dale, I'm going to turn the program over to you.
So that's where this plays out. I do have some business background stuff, doing antenna stuff. I worked for Shively for 11 years. I left for 10 and a half to go to Dielectric. I've been back for 8 years, so we've been playing the game for quite a while. It's kind of an interesting thing to do. I'm trying to get some information out here basically on some antenna design, on maintenance, and maybe when you ought to be thinking about some replacement parts. I had initially tried to have a filter for show and tell, show people what's inside of one. So I guess what we're talking about here: installation, maintenance, repair, and replacement. Antenna design is going to be some stuff that I may not know that much about. I'm going to show a few things, but it's HFSS, all the computer-generated things that other people can do that I sit there and go, that's really cool. So we'll go into a little bit of that. I kind of looked at this in a little bit of way. I know you guys probably know way more about this than me, but I just kind of went through my own mind how I wanted to approach it, look at the different parts and pieces of what we look at when we're trying to do an antenna design. One of the basic parts of this is what type of polarization. There's different types. Most of them will utilize CP or circular polarization. It's more effective because you're putting equal powers into both your horizontal and your vertical. There's some other variations of it that can be done, and your splits may not necessarily be circular, they would be elliptical. So a lot of your broadband antennas that are out there now, the big double Vs, if they're opened up quite a bit, if it's a broadband antenna, those aren't any circular antenna. They're more elliptical, and they're probably an 80-20 mix. So you're not putting out vertical and horizontal equal. The gains on most antennas for your circulars and such, they're going to be, for different manufacturers across the board, they're going to be similar. When you get into some of the other variations, your horizontals, your verticals, and these weird elliptical antennas, the gains are going to be a little bit different on that. Basic circular antenna. Of course, this one happens to be a Shively. But you've got vertical arms, you've got horizontal components. That's giving you pretty close to a 50-50 split. Another example, same type of thing. It's made differently. This one is made as a circular antenna, even though it is a twin dipole type. They're a little flatter, so it's made to be CP. Something like this, another manufacturer's, same idea. The rotation, the changes of it, there still has both components, even though they look different than just having a straight vertical and a straight horizontal. Panel antennas, they do both, horizontal and vertical. There are some panels you can run that are horizontal only or vertical only. We've done some of those. They're very rare, but we have done some of those. Whoops, back up here. This design is vertical only. The basic dipoles, they're all in series here. Some of these will have a straight arm. Some of them will have a swept back arm at a 45 degree. In the past, most of these were used in situations where you had a channel 6 in the area that you had to protect your channel from their issues. That's going away in a lot of places. There's very, very few that are still licensed to be able to have a vertical antenna in the area of a channel 6 type frequency. Frequencies were close, that's the reason, and FCC was saying that they didn't want any crossovers. Vertical antennas are going to have a power gain about 0.92 to 0.95 per VA, and as they stack, will increase in gain. So you're getting more gain out of a vertical or a horizontal rather than a CP antenna. Horizontal only bay, something like this, for our design, is basically the antenna that we showed it first off, but it's missing your vertical arms. It doesn't have an up and down arm on it. It's just basically the box part of it. Not so much used currently, except for the small low power guys have the option to do horizontal, vertical, or a CP antenna. They're the only ones I think that have that ability. There's a few of them I think that we've done in the past. Canada was very strong on horizontal antennas back 70s and 80s, but slowly they're starting to replace those antennas that we've had out there over time. Slant polarized. It's something we're seeing an awful lot since we came out with this design for a log periodic. It's beefy, it's overkill compared to what other people have had. But we do an awful lot of work with this based on it, and the rotation of it, it varies depending on what we're trying to match for your H and V ratios at a slant at that frequency. We do a lot of very directional antennas with this type of a design, and the variations of it, it's not circular powered, it's a linear polarization as opposed to circular. They're not work the thing, it's not running in a circular wave to get your pattern out there. To talk a little bit about the electrical properties of the RF. There's roughly two different style antennas that are out there, two schools of thought, as you want to call it, for exciting the electrons on the bay. An externally fed antenna is normally where the feed point's on the outside of the antenna. This is your feed point, and that's basically what creates your driven power that's going out to two different arms on either side of the antenna. The other two are basically what we call a dead arm. They're not driven like the others are. It has a feed strap, which is the piece that goes across that connects to your feed point. Most of the antennas, and it's not just the Shively types, there's a lot of the Jam Pros and others will use this style. The other style that's out there would be the internally fed, which is an ERI or PSI. A lot of these use this same basic thing. And basically within your arms, this one's got a red stripe, this one's got a red stripe, those are going to be the two driven arms. And within here, there's a stinger, which comes out to feed it. And then the other one, this here, this arm and this arm, those are opposites, but those are also kind of a dummy arm. They're helping to propagate, but it's still, they're not fully driven. Looking at some of the different other electrical properties, the difference between a rigid or series fed, rigid line, and then we'll talk and look at a branch fed system. The rigid coax, it's been done for years. It's your inter-bay line. It's everything that's powered. It's solid rigid line that goes into between your bays. They're a fixed length. Your bay to bay spacing is normally the same across your antenna, unless you've got beam tilt or something like that, which may alter that slightly, or if you have something that's less than a full wave spacing. But there's still going to be a uniform spacing in most cases. They're designed to be a single frequency in most cases, but there's always those that we broadband and put one or two frequencies. They don't have the broadband capabilities that other antennas would. You can only go so far without losing your VISWAR and some other issues on it. The elevation patterns are very predictable on a design like this. You can do half wave, you can do 0.75, 0.8. It all happens in the back into your interbay lines here. And a lot of it just by slugging the line. So if you want to do something different than like a 3/4 wave, there's basically a large slug, either polypropylene or Teflon it used to be before it got so expensive, to fill that line to adjust it to change what your wavelength's going to be. Branch feeding. Branch-fed antenna is going to have a power divider or multiple power dividers, and it's going to have interbay cables that feed the system to each bay. This layout here has got multiples of this is a port, this is a port, this is a port. Each one of these is a port, and this would be fed off probably a master, so it was maybe a three-way to start with, breaks down to multiples of other three ways. So depending on how big your system is, how many bays, how many panels, that's the type of system that you're going to end up as a branch-fed system. This is something that people see more nowadays. You've got a six-way power divider at the top of a piece of line feeding smaller, lower-powered antenna. A lot of the antennas that we're doing now are non-pressurized systems, and this is what you'll see. You can pressurize up to a power divider, and it has foam cables. In a lot of cases, you don't necessarily even have to pressurize this system because you don't have to worry about the antennas or the power divider can work with or without pressurization.
Question for you on a branch feed system.
Sure.
Similar to this. There's been a discussion with a couple of folks have been around. In the branch system where you've got the power divider and you're coming out to the individual bays, and this is a fairly low power system. Mm-hmm. The interbay cables that go from the power divider to the bay itself, of course, they're all the same length, which is the only critical thing.
In most cases,
the same amount of power each one, but which means some of them are way too long versus the others are far away. Discussion was, should the coax be spread out or coiled up? Somebody said that if it's coiled up, it screws up the efficiency of radiation or whatever.
There's different thoughts
on
different antennas. It can be coiled, and we recommend in some places, but it depends sometimes where that coil lies. You don't necessarily put it right up behind the antenna bay. You put it down at a location that's out of the way, that's not behind a driven element, and that's usually what we see and what we find. Another way to fix that is if somebody didn't want to have the extra coil, if you had an 8-bay antenna and of course your ones in the center are going to be much more cable, 20-footer or whatever the length of the cables are, coiled up there, and as you get further out, then you're going to use up the lengths of your cable. Some people don't want that, and so what they'll do is they'll do a two-step. So you'll have one power divider in the center, split out again, so you'd have a two-way and then split into two four-ways, and there's just less cable if somebody wanted that route. But of course, it's more expensive.
Problem would be not be from that the coax is coiled up, but it would be the position that's coiled up in relation
exactly
to the radiated element, because it actually is making depending on the size of the coil, I guess could be almost resting in that circle.
Exactly, and we've seen it more. Our low power antennas are the more irritable ones on this type of thing, and because of that, we now, when we ship one of those antennas out, we coil the line, we put wire ties on it, and a big note: do not uncoil this and move it from that position, just to make sure that when they put it up, it's going to react the same way. If they don't and they try to move it for whatever, there's something else in the aperture, or
So spreading it out and just making the line go up and down the tower and attach it.
And on something, and an antenna
get it out of the way would be the safe way to keep it from being in the wrong place at the wrong time.
Yep, exactly. And something that's very narrow banded, that's really going to play havoc with it. It's going to detune the antenna just in that one bay and make it a mess. So
antennas are broadband bays, but still, it could be resonant at the frequency you're using.
Yeah, no, it can be. Yeah, exactly. So when we're doing that, basically your installations require a calculation in a branch fed if you wanted to do other than a full wave spacing. So basic formula on this, you guys probably all know, it's 11,803 divided by your frequency. That's going to give you how many inches of your spacing is predicted for that. Some of the antennas that we're doing now, the broadband ones, have a specific dimension between bays, even one of our panel antennas. To get the best broadband response, we're stating it should be 108 inches bay to bay. Our broadband 6832, same way. It says 98 inches, and then if you want to get the very best across the band, a half wave space would be 77 inches. So there's certain parameters that are out there that can be calculated to find out the best situation.
Since Wiley's not here today, I'm going to be the question man. Somebody's got to take his place.
Yeah.
In the situation where you've got a multi-bay broadband array, say a 6 bay that's power divider in the middle, whatever, and you're spacing, if you're not concerned about the antenna necessarily being broadband, but you want it to be the most efficient at the frequency operating, would you do spacing with this 108 inch between, or you need to space exact to the frequency for full wave spacing?
That's one that I would, if I was an engineer, I'd be able to answer very quickly for you, but I'm not. And I know that I've asked that question myself. What if they just put this at the maximum length of what your cables are and that type of thing? You can do that but it usually becomes that whole thing about if you're buying a broadband antenna and you're going to use it at some point for that, that's why we've set it up for that 98 inches, because most of them, that's the reason. Well, for this, for our 6832, the dual arrowhead type, that's 98. For our panel systems, they're 108, because that gives us the best response from 88 up to 108. If you were setting up an antenna that was a single frequency, and it's always going to be a panel antenna at a single frequency, and we've done plenty of those, then you could use that and calculate and come up to exactly what your spacing is.
The 11803 divided by the frequency to get the inches of spacing.
So, I mean, there's no need, unless there was some hint that you may want to do that broadband down the road. And there's no reason you couldn't replace that down the road either. You know, if somebody decided to say, hey, I bought this as a singles frequency, I want to change it, it's just the power dividers and such. You can take that and swap it out.
The antenna that I'm talking about, and this is a weird thing that happened to us, is it's always the reflective power has been a little bit higher on our particular frequency than I'd like it to be.
Yep.
But I mean, it's within reason, you know, for a broadband antenna system. But we had a storm come through and actually twisted some of the bays, and they twisted where they weren't lined up. Well, the match went to almost a perfect match. So that got us questioning, why did it go to the perfect match by changing? It didn't change spacing, it just changed the angle of it.
Yeah.
And so we got the question, do we have it spaced right? Is it because the cable's coiled up?
Sure. Yeah. Now, are you on one end of the scale or the other? Are you at 88?
It's on 100.3. So.
And there's some like ours, that's a happy spot, is if it runs in the middle, you get a very good broadband section on it, and they taper off on either end. So it depends on the antenna and what you're using. So, but the variable wavelength, certainly on a branch fed, is much easier to get together and put up. It's just a dimensional thing, and you can set it up that way. But you need to settle for a compromise on VISWAR when you're using one of these broadband antennas. They're not going to be a 1.06 leaving the factory or going on your tower. They're going to be if you get 3 frequencies in this and it's covering 10 megs, you're going to be looking at 1.3, 1.2 at different places. Each frequency is going to be at a different spot. So. Elevation patterns. I'm just going to touch on this thing. We've got full wave antennas, halfway space or variable spaced antennas. The antennas are going to be mounted where the main beam of the pattern is basically perpendicular to the tower, and it's aimed horizontally. So this is an elevation pattern, but if you rotate this, lay it on its side, that's going to be what you're putting. You get your main lobe, and then you've got multiple lobes down here. Usually on your tail of these things, that last lobe is the one that you worry about when you have issues with downward radiation and such. That's the one that can be controlled to change your angle. Typical elevations or pattern on these without beam tilt, more than half of your total radiated power is going to be above the horizon when the Earth curvature is taken into account. If you laid this on its side and with the curvature laid all that, there's all sorts of documents in the NAB engineering manuals for this. But half wave or any other variable bay spacing between half and full is going to help with your downward radiation if that's an issue. Just a simple, if you went a 0.9 wavelength compared to full, you're going to see a big difference on what it is for the angle coming down. It's going to reduce the tailpiece of that. The gain will usually become less once you go away from full wavelength, except for the happy spot on those, somewhere around 0.9. Some of the gains will actually go up, so you may get a little more gain out of your antenna based on that particular ratio. Look at a little bit here going into some beam tilt information. In order to get the furthest area on a height above average terrain, the beam may need to be tilted down towards the earth. I don't know how much you folks see this, but there are some locations that certainly have this issue. Electrical beam tilt is used in most of these cases, but mechanical beam tilt can also be done on the antenna mount to change the angle physically to come down a little bit at an angle. We've used a design like this in places like Colombia. We've done some antennas down there. I don't know if you've ever seen maps of down there, but they've got these huge ridges that go around the main areas and straight down into a valley. It's very steep angles and such. And they don't want to, they want to hit some out, but they also want to hit some of the areas that feed out on the way. And to do that, we've had to create some of the antenna mounts that have they're not a huge angle, but when you look at it, but you actually have to change the angle coming down. They're I think 5 degrees, I've seen some of them, 3 degrees, but that little bit that tips the antenna down just to cover coming down into those really tight valleys. And there's some places in the US that we've done it as well mechanically. We do much more of it electrically, and that's a different way of doing that. In order to do that, we're basically changing the lengths of line sections above and below a center fed antenna. So you're shortening one and adding to the other, and that changes how basically the phasing is sent out. So one example here, there's your center input, the center feed coming in. On the top, this part here, and the bottom part, they just adjust, and it's a mathematical calculation how they're doing that to get to that. What's that?
Dim the lights a little bit. There.
It's time for your nap.
Yes.
But basically, that's all we're looking at for that style design. There's some much more thought into it. Again, I apologize for not being the engineer that can really get into some of this stuff for you. No fills usually looked at when there's a need to fill the service area within the radius of the first null. Let me back up to this. Most no fill is, whoops. It's when you're trying to change the first lobes going into here that you can add null fill. It just changes how it's reacting with that first major lobe. We don't use it an awful lot, but there's certainly, and that comes to us most of the time. The folks that are doing the pre-work ahead of us, we can figure it out, but most of that stuff comes from a consultant. They've already done the pre-information. They're looking at your downward radiation. They're looking at your beam tilt. They're looking at all this type of calculations. They use us to offset it, but most of that information comes to us in hand for us to build our antennas. Going back to a little bit, talking about downward radiation and how to contain the your downward, but the potential exposures and that type of thing. The FM models recently been updated and some stuff has changed. They've gone back in time for part of it to back in the 1985 when they were looking at this information, but we've also been allowed to go and change some of the newer designs and have them get input into their system. But basically it's changing and giving you how, if it's a pass-fail for the antenna and how it hits the ground level. So however far out you're going to be, how much power is going to be hitting the ground at that level based on what your height is, your power, a bunch of different variables. We had some issues with this in the past. I remember going back and forth with the FCC a lot. The ring-style antennas, as they're called, they fail on some of these if they're very low to the ground, or the distance that they're measuring it out is going to be an issue with some of those. It depends those two parts. One of the simplest ways to correct that is just by going slightly off full wavelength spacing. So if you go to 0.9 or 0.85, that may correct everything, and you're going to have certainly a pass and no issues, no questions on it. Our other antennas don't seem to have the issue as much, but they're like 6812 low power stuff, and we've got some other that have shown that. The change in the lobes is going to diminish any of that downward radiation. It's changing the angle of how it hits out, but at the same time, as we talked about a minute ago, that will change your antenna gain as well. So you're going to lose gain by changing and dropping your power that little bit. Often, just that 0.85 or 3/4 wavelength will really change it to make it, and you're not losing as much gain by doing such. This is how the FM model is set up. You've got your EPA types on the pull-down list. You've got a ring and stub, opposed V-type dipole, opposed U-type dipole, 2-piece spiral, and then a 3-piece or a 4-piece spiral are your options to go in here. You pick your channel, your frequency up here. This is the other information you put in there, your height above ground in meters, your distance out, your ERP, what you have, 100,000 watts in both horizontal and vertical, your number of elements, and then your wavelength spacing. The number of points is how many points it will draw on this chart on the what it exports, but that's, you don't have to have a 500, you could put less and still get the idea of what the result's going to be. But it allows you to go and change your element spacing in a formula like this, and it's going to tell you if you make or break basically on it. And this is on the occupational controlled exposure. This other one here is for your general population exposure. They have two different ratings, the 33 to 330, or the 30 to 330, of course, that's within the FM band. That's got a rate of 1 milliwatt per centimeter squared. And then your general population is 0.2. When you carry that out, in the information that we see, the 0.2, if you get it into what they print out, is going to show at some level. I don't know if I didn't have that screen on here. Here we go. Like this one is coming in, that information that we had in there, it shows up as a 405, but it's not a millivolt, it's a microvolt. There you go, thank you. That's my brain working on that. Microwatt. So you've got 3 points carried out. So that 0.2 that it showed, we would be looking at if it's over 200, then it's going to fail. If it's under 200, it's going to pass. So this is obviously going to be a failing number on this. This is how many meters out, and this is your 17.4 meters is that's where it's going to fail. So. Get into some antenna models. You guys have seen thousands of these, I'm sure. There's different types. Each one has its own property. You've got ring and stub type, double V dipole, opposed U, just as basically running down through the same list that we looked at a minute ago. 2-piece spiral, 3 or 4-piece spiral, panels, dipoles, log periodics. Basic, what they call a ring stub. We don't really call this one that, but that's kind of what it's tiled into. It is a ring style antenna. Your double V, there's plenty of these out there. This is opened up, as we talked about before, as a broadband antenna. It's opened up to get more frequencies. The ones that are closer down, they are more tunable and more single frequency. They call this an opposed U style. This style here, you would say, well, it looks kind of like a double V, but they've rated it as a 2-piece spiral.
What's different about them?
It has, and I'm not sure. You can check with OET, the FCC guys. They know how this is. I think it has to do with the formation of this, the whole size of it coming off where you're fed and then that type of thing. This one is formed. It's kind of,
okay,
you know what I mean, but it doesn't.
Rather than straight out.
It is. It's just slightly different. And it's more of a spiral if you kind of flatten. I don't know. I'm not sure why they did it, but they did. This would be a model that's more, a 3 or 4 arm spiral type design. Your panels, there's multiples of this. This is a basic single in the center. They make other types of panels. There's cavity backs. There's the flat backs. There's flat backs with angled radiator arm pieces on them. But they're all similar in what they're doing. underneath all that ice, there's a single dipole. And I know you guys don't see this kind of stuff, so it's fun to show, just like our good Canadian friend up there. He likes to throw these in every now and then. But this is a dipole antenna, just a single bay, tucked underneath all that crusty rime ice. Here's a fine matcher. You can't really tell, but it's right there, feeding into it.
The ice helps the signal go further, right?
Sure. Sure, when it comes off. Yeah. Yeah. And this is a log periodic. What we call log periodic. I mean, you've seen tons of them. Scala makes them, the real simple die, aluminum, lightweight, little thin arms that usually last about 18 months, and something happens. So, get into a little bit of capabilities, omnidirectional type antennas. This type of thing, this is probably the most omnidirectional pattern with an antenna that we can produce. This is using what we call our Lindenblad. It's a top-mounted four dipoles that go around in a circle on a pole. We've done some of these on up to a 24-inch square section. Any more than that, it just gets very squirrely and cumbersome. But this is going to give you very omnidirectional. Your H and V are quite similar. It looks great, and it works great for doing that thing. It's a different antenna than most people are used to.
Is that a circular polarized, or is that?
Yes, yep, circularly polarized, yep. Something like this is a basic side mount, one of the other ring style antennas. Side mounted, that's off of a pole, but we still call it a side mount there. And that's your basic patterns, but there's nothing changing anything on this particular thing. It's just how it was taken before they started to get, and they wanted to make it so the H and the V overlapped each other. This would be the same type of antenna on a 12-inch pole. The patterns change. Swap over a little bit. This is what happens on a 36-inch tower structure. It gets squirrely fast. And this one is they've tried to compensate for it, try and balance the H and V, and it uses a two-leg pickup, we call it. So it attaches to this leg, and then kicks out away from the tower. I think it says, yeah, this 22 inches standing off of the tower, mounted that way. Just trying to get it back in so they're overlapping and performing well. But that's what you see with your tower, your irritation, I call it, of the tower. It's not the relationship, but the irritation the tower causes for these. This is that same style antenna on a 12-foot face tower. And this is, I don't know if it says, but I think it's right there. They're standing 4 feet off the tower. So closer, it was nasty. This is the best thing that they can do to get it away from the tower and still have something that's a decent coverage area using that style antenna.
Dale, when you put something up like that and file for it, is that still considered omnidirectional for FCC filing? You can't file for directional, obviously.
No, but that's the fine line that we get into with every one of these. When you side mount an antenna on a tower, everybody knows that there's going to be issues and relationship things between the antenna. They're going to fight with each other. But if you're just bolting that antenna on the side of it, and in a case like this, I'm sure what they did to bring it off the tower, that was helping to match the H and V. If you're not increasing the gain of the antenna and you're just trying to balance the 50-50, between the H and V, it's still an omnidirectional antenna. You're trying to help it to do, basically what it's designed to do. If you were changing something and you were driving everything off in one direction, or you're adding parasitics to make something happen to it, to really direct it, that's where it becomes a thing that now it's a directional antenna and not an omnidirectional antenna. The FCC realizes that whatever you put it on is going to change how the signal is. A big tower like this, normally, it's going to pull, your vertical is probably going to stay, but your horizontal is going to be pulled back into the tower. And it does fill back quite a bit through here, but it's being pulled back into it. So to balance that, they've pushed it out that 48 inches just to try to make them at least cover the same similarities. All of those were considered omni, but you can see how they're affected by leg placement, face, how far away you are from the tower. Each one of those is a thing to think about and how you're going to do it. They all have to mount to a tower somewhere and have distortions based on that. Reiterating that, any antenna that's placed on a tower structure is going to have some form of pattern distortion. A pole 6 inches or less mounted is going to have minimal changes to the free space pattern. Once you get the tower structure behind it, it's going to get more complicated. They're going to be added bracing. There's ladders. Some of them have a star mount on top or a candelabra structure. Any of that stuff is going to make things very, very tricky to get a decent pattern tucked into it. Some of the different structures behind your tower details, you've got a pole mount. Your straight tower sections is basically a 36, 24-inch face. It's all the same all the way up through. The bracing's the same, everything. Pretty simple to work on if you're looking at it that way. They've got 3-leg towers. They've got 4-leg towers. Your bracing, it could be a K brace, could be an X brace, could be a Z brace, could be an M brace. Those are the consonants I know that this stuff ties with, but there's other types of bracing that we see, especially once you get out of the country. Some of the stuff they have internationally, it's amazing on how some of those are put together. Then you've got monopoles. The monopoles can be small. They can go up to 30-something inches in diameter, tapered from top to bottom. You see a lot of the cell towers are a monopole design or other styles out there. And then, of course, tapered towers. If you've got something at the bottom, they're 20 foot wide. At the top, they're 3 foot wide. Every level of that is going to be a different measurement, a different structure, a different iteration with bracing on how it's going to affect any type of an antenna. Something like this is just showing, some of the basic, this type of very basic bracing. Some of the Larone stuff, the smaller stuff, just use the zigzag. This is kind of a K type. This is a Z, X, X without the horizontals. This is kind of an upside down M, and this is an M type, or the other way around. Each one of them, they're just different variations on these. This one's got a little bit of a problem with a lot of, it either has a lot of downward tilt or upward tilt, one or the other. It's but it's your basic monopole.
Is that one that Jim showed earlier that busted off?
Oh, this is a little different. I was thinking, I looked at the difference to see if he found the same picture I did on it. But we get a lot of folks that are trying to, they're trying to attach on these things down below all the crazy cell stuff that's going on these, and to try to find out the actual dimensions of that, and they're all tapered, so you're going to have to, almost every case, you're going to have to offset onto a pole, because you need to be plumb and have your signal. This one, it wouldn't matter so much, but on one that was installed and in solid good shape, you'd be all set. Let's see. Directional patterns. Some of this stuff, they're created to fill an envelope pattern. It's created by a consultant, an engineer, or sometimes it seems like some 6-year-old with an Etch-a-Sketch just sitting there playing, just sitting there what you can do and whatever. Each one of them has a reason why they're doing that, because there's a bunch of stations around here that are pushing in, and that's what they're allowed to do in most of these cases, and they have to fit within that parameter. A class, let's see what we got here. The rules vary as to how and what the specifics of a directional pattern are when comparing a Class C to a translator. Class C is going to have to report back to the FCC. They're going to have a proof done. They're going to have documentation showing the pattern was done, how it was done, what the pattern is, what your gain, all that type of thing. Your translators, not so much. They can, they have to certify that they've done the work when they file, but a lot of times that the guys haven't done a thing about it. They just slap up on a broadband antenna, say they're fitting within a envelope, and calling it good. And the problem we see is that every time that somebody files with an envelope size, like something like if they filed with this, once it's on the FCC site, it's there forever, and somebody says, oh, they filed this with a Shively antenna, and I can do that, so I'm just going to say I'm going to use a Shively antenna to do that. But I was just talking with the FCC 2 weeks ago about this exact same thing. And they don't have any, they're cutting back. They don't have anybody that's following or chasing this translator stuff. But to me, it's going to be a problem in a couple of years because you're already seeing stuff that's showing up in the trades. There's translators are having issues with each other. People are getting forced off air and stuff like that. And it's going to get worse before it gets better when people are just slapping an antenna up there, totally ignoring the fact that they are supposed to meet some type of directional envelope.
One other thing to mention as the end user, if your consulting engineer submits an application for a CP on a full service especially, and he says this pattern will get granted, and it gets granted, there's still absolutely nothing that says it's physically possible for any antenna manufacturer.
Absolutely.
on the planet
Absolutely.
to get that pattern.
We see these all the time.
This pattern
Yep.
will pass the population requirement.
Yep, exactly. That's if you get something that fits within this. I mean, if it's a true directional for this, you have to meet 85% of what's there.
Oh, I could do that with a panel antenna at $50,000.
Exactly. And nobody wants to go that route. And that's because it's a lot of the low power guys and the translators that somebody's developing a pattern and they say, here you go, this is all you got to do. And then, they collect their money and off they go. And then this poor guy is stuck having no idea what they're doing and trying to figure out how to fill the pattern to do it, do his due diligence. So it's an interesting study we're going through. I'll get back on track here. But basically, to make sure the FCC is doing that, you have to cover your city a license. But we're also taking into account, your tower, what your structure is, everything that's in the aperture of the antenna, your leg orientation, all of those pieces tie into this on trying to match what the pattern has and how it's set up. It can be done with a duplicate of the tower section, which is full size. The ERI does full size pattern work. In my little box of goodies that's over at the hotel that shipped in, I had a scale model because that's how we do our stuff. It's a 4.5 to 1 scale size. We can do multiple iterations of patterns for trying different things, for different mounting and structures and that type of thing. And I brought one of the smaller models here just to give you guys an idea how tunable they are and all the different components that we have to do, let alone have all the different structures and scale size towers. We have a full 2-bay garage, upstairs, downstairs, with just tower structures front to back in the thing that they can go pick and choose. And some we had 2 weeks ago, we had to build a custom one, which is rare. We've been doing this since, for over 50 years, but we had to find one that we didn't have a structure that was made just like that. So we had to weld something out that was put together right. So, but we're get back on here. Other options, like I said, was to do the scale models and then have the ability to spin the patterns that way. This first slide is showing something was created. A lot of people use it's a ComStudy, or there's some other programs out that allow you, if you have the parameters around there, you can see what other people and how they're pressing in on it, what you can come up with for a pattern. That's where this one came from. There's certain rules they have to follow per point. I think there's a maximum 2 dB change between points they're supposed to have on there. These don't always do that. And then you must touch on the outside of your pattern at least in one point. And it can't be for a little pin needle. It's got to be for a certain amount of points as well. The antenna it can't fit into a tight corner as well. It's something like this little area here. If that's where your city license has to be and you have to cover that, it's very, very hard to think that you're going to be able to get your pattern to nudge into something in that an area. Most of them have a smooth, rounded flow. Acts similar to a balloon, so when you push in one area, it's going to squeeze out in some other spot. It's just inherent in how it is. And you can do that with your mount offsets, how far you are, if you're coming off at an angle from a straight, as well as a parasitic element can push your horizontals or your verticals to change a pattern, to drive it away from the tower or to kind of make them overlap a little bit. Based on that other pattern I showed you, this is something that we were able to do to fit within that pattern, something that's narrow and also fits that little tail. The reason we came up with our own log periodic was just for patterns like this that allow us to do something narrow And then you've got down here in the bottom left, you've got one antenna in one direction, one antenna in another direction, faced off at different things. And then you've got your attenuation on this, so you can cut the power. So you have a two-way power divider feeding this. This one is attenuated by 10 dB as opposed to the full 0 dB on this top part of it. But it was something that you're handed, try and do something with this. We came up, I think we went through 3 or 4 different iterations of antennas to see what's going to work best. Tried a couple of side mounts, but they're adamant about trying to fill this tail. And in the past, nobody would go to that extreme. They always said they knew it's going to be a basic cardioid. We know what we can do. But now everybody's trying to fit into the little tightest areas. And of course, city license is down in here. So that's what they have to cover. So, but we're able to do it. And with a bunch of time, energy, a little bit of patience mixed in, we're able to do that. This is the basic pattern on a 52-degree rotated log periodic. So we had that to start with when we finally got away from doing the side mount type, the basic side mount, to look at something like this. So this, this would fit nicely into that part. It didn't have anything coming out the back as a standalone. So we had to do some different adaptations on it. I'll continue on this. The previous pattern created by slant log periodics, and it was a little bit narrow. It wasn't real narrow. If you had taken 2 of those log periodics and put 2 of them side by side, it will narrow the pattern up even more. So you've got that other one was a single lobe. I don't have a picture of how the other, but it'll make it tighter and fit into more places. We're doing some of that too, but that gets different. So now you've got to have some kind of a structure to support 2 log periodics coming off at a slant if you wanted, or a vertical. Most of them have been a slant. So you have 2 of them coming off, and you can, depending on your tower size, that's usually the killer on what's going to happen with what you've got. You're not going to do this on an 18-inch face tower with 2 log periodics hanging 8.5 feet out and that type of thing. So something else we've done, which is even more crazy, and I've only seen once or twice we've done it. This type of a pattern was created. It's a panel antenna, and there's 2 panels side by side with 6 feet in between them. So you get each panel's 8 foot, so that is 16 feet, and then you've got another 6 foot space in between them on one side of a tower. But you can do, as I think Josh said, there's things you can do with a panel antenna, but at what cost? Now you've got this huge structure. You're going to have supporting members on it that go out, so it's going to be an outer structure on your tower already to get to a design like this. And then a lot of times these are something like this, they're going to want a multiple levels, so it gets very busy, very expensive, pretty fast. So this is what your standard panel is going to look like on a 7-8 foot face tower. It's scallopy, but you've got a good uniform. You're covering all around the tower based on this. You've got 1 panel mounted to each face of the tower. You can change some of that by spacing a little bit off the tower. You can still fool with that a little bit on your spacings, and sometimes you can kick them off at a little bit of an angle to do. Another iteration looking at patterns. This type of thing was something that I had to really talk to our pattern guy into doing. He wanted nothing to do with it. But he finally sat there and said, I'm going to try it just to see. In the past, we've tried using 2 antennas back to back on either side of a tower of the same type. So if you have 2 ring styles or 6810s or something on either side of it, they fight with each other. They always have issues and that. Both of these antennas, the 6815 on this side, and then this is a 6025 log periodic, but they're not designed similarly. They have different properties, and they both seem to push things away from the tower inherently without changing much of it. So what we ended up doing on this side of it, it's our 6815, which is a base. This pattern on this side is a basic cardioid, which a lot of people are using for a basic directional antenna. So we knew that could handle that side of it. But then they were able and tried it putting the 6025 on this side, There's some phasing issues that were had to work out, but this is the solution that we came up with. Customers happy as can be because they didn't have to do any crazy panel, because that was the other side of it when we were looking at it. They were talking at multi-level panel antennas, and this saved the cost by quite a bit for doing it. Down here it's showing there's a parasitic that goes behind the 6815, and this is pole mounted to get it a little bit away on this, and this has got a 10 dB attenuation on the log periodic part of it.
So in that case, you actually use like a 10 dB power attenuator up at the tower?
There's a couple of different ways we do it. We do our own attenuation at the power divider, so you can add sections and attenuate sections off the power divider there. In some of these ones that are over 10 dB, that gets into a different world, but sometimes we're able to use, if you think back to the early days of digital when people were going to do that, we were using the injectors, and those had a 10, they were a 10 dB hybrid basically is what they were, but they were up on a tower. Yeah, but they're on a tower and that type of thing. So we're using, in some applications, we're using some of those injector designs to be able to change the power structure to get that 10 dB power feeding into it. So each one of these, it's a little science project, but that's kind of what we're in the business for. So.
That's here. That's here.
Could be. It's not yet.
Okay. Oh, okay. I know that story now.
It's a secret. Whoops, I wanted to show you just one more thing. The way that we're doing these patterns, too, if you weren't aware of that, but your green is going to be what your predicted pattern's supposed to be. That's your envelope that you're trying to fit in. Your red's always your vertical for us, and the blue is your horizontal. That's how we look at these patterns. So. I did this, pulled some of these off. This is just going on to the FCC website, and I put in a state, which was Massachusetts. Just go to your basic FM query, and then I put in, what was my parameter? I think it was, no, this was just a search on just Massachusetts. I started scrolling down, and I started popping as I went down, because now the FCC shows these little pictorials as you look down through. And I just started copying these each as I go. It's showing you how many different patterns that are out there now and what people are trying to do. In the past, most people, you don't see any patterns. It's omnidirectional. They don't, you're just going to put something up on a tower and they're going to run it. But this type of stuff is coming out. For this one, the top row, I think this is the one. These are all translators. Every one of these is filed as a translator. It's exactly what I come up, because that's what, if you're an FCC directional, you have to be the 2 dB. Obviously, these don't. But like I said, any kid with a little Etch-a-Sketch, these things, they're crazy on what they're coming up with, just trying to meet and fix. To me, that's easy. There's the log periodic. This one, that may be 3 log periodics. It's not any other way unless you're going to put a panel system. And for a 200-watt station or 250, you're not going to put although we have done some, but most people aren't going to do it. Another log periodic here. This one's got a little bit more to fill. That's going to be a toughie, because more than likely this is a city license up here. So, if you were doing there and there, but that, again, that may be something with log periodics doing that. This is simple. All these ones that are a cardioid, that's great. This one, the whole corner thing, I don't know why people, because there's no way you can tuck a round pattern into a squared off corner like that. But one of these patterns would go fit in with that, and you should be able to be, but they don't have to meet the 85% rule either. So this one's a toughie. You may be able to do something here like I was showing that last one, the 6815 style side mount, but then you've got an offset log periodic maybe coming down into this little tail here. But that's the kind of stuff that we're seeing out there right now.
Dale, how realistically, once you do these patterns at your plant, how realistically is that pattern going to be once you ship it to Joe Bubba that's going to put it on the, up on top of the building?
If we're doing those, we're doing the full model. We're doing, as much information as they'll give us, and that's like pulling teeth too sometimes. That, the guy's out there holding his thumb up, trying to. They always want to tell us how tall the tower is. I could care less how tall your tower is. It's nothing personal, but.
The reason I brought that up is a funny little story. A guy called me from the station, and he said he had a call from the church and had a translator.
Yep.
And he wanted to know could he put his translator antenna on the broadcast tower because it's up on a hill. He said, "What did your CP say?" "Oh, it says it's supposed to be down here at my church, but we're down in a hole, and you're up taller than we are. Can I just move it up there?" So yeah.
That sounds like a day in my life. We get those phone calls all the time. Because a lot of those, they don't really use consultants. They use friends of friends. And there's usually an engineer tied to it. But it's a lot of, they're trying to help each other out. And there's always somebody that doesn't know the right answer in the picture but doesn't say it. Or they don't tell the people, that you can't just do what you want. But there are some opportunities that the people don't understand too, that you can, depending on what your parameters are, but you could be up on that hill to broadcast to cover more, but you're still limited by power, or you have to decrease your power. Nobody's telling them all that information on and how you can change the rules on that. So.
Or coming back to what Jimmy was talking about earlier about actually communicating with your tower folks, letting them know little details like which leg was actually studied as the mount point when you plotted the direction.
Yep. Yeah.
Is,
You're way ahead of these guys already, Jeff. They're not even to that.
Consulting guys that have looked at it and go, if we rotate this pattern 120 degrees by mounting it on that leg instead of that leg, we'll cover that town a whole lot better.
Yep. Oh, exactly right. Yeah.
Which is fine until the FCC actually decides to hire enforcement bureau people.
Yeah.
So I guess it's all.
Oh, yeah. But we get into the conversations that the guy's saying, well, the highest point that I can put it is the only thing we've got that tall is the cross on the church. And then they start talking about mounting a pole to the back of their cross on the church. And something just really sounds like you're going to introduce yourself to a lot of people being upset if you're trying to I get what they're trying to do, because they're trying to set up a station for a lot of these little churches and stuff like that. And if everybody understands and is happy with it, but that just seems like you're getting a little bit on the edge of trying to cross over. So. This grouping here, this side, same thing. I just went in and popped in, and this was Florida. And it didn't take very long because there's tons of stuff in Florida. This is 10 minutes a time. It took me longer to copy, cut and paste all these. All of the top ones here, those are full service stations. So they're not the translators. So they're still the full service ones. They're still trying to fit in at higher power to mix and match and try to fit into some of these. And these are all open CPs. It's all happening right now. And then down below, this started off, and the rest of these are translators going down. But of course, your translators don't have to file a proof. All they have to do is say that they've certified somebody has, that they're going to fit within the parameters of that pattern. And it seems like a lot of them aren't doing that. Which, I mean, it's not just about the money that I'm talking here. It's just the fact that in the next couple of years, you're going to realize that a lot of these people are stepping on other people, and it's going to become, it's not warfare, but it's going to get real nasty here pretty quick.
I mean, I can think of two locally where their ERP versus the actual license, there's a factor of 10 difference in some cases.
It is, and it's exactly it. And then once they realize that, they've got listeners, and then they start looking, and then they're turning stuff up, and it's a strange little game that people aren't following the rules, and not even including the whole pirate thing. The pirates, that's a whole nother beast of its own. So, yeah. Basic mounting, side mounts, top mounts, panel mounting, a side mount, something like this. There's lots of side mounts on this tower. But they're mounted on the side of the structure. They're leg mounted, they're face mounted, they're offset on a pole or appurtenance or whatever you want to call it in there. But there's just different iterations in how they can be. What's that? Yeah, you get a bunch. You get, yeah, that's a cross pole one. Which, yeah, this one also is just a weird angle, but then you've got some other, there's a side mount FM. Here's another FM. In most cases, we don't recommend people using the same aperture at all. At all. You go out of the country internationally and stuff, and you'll see they've got a 100,000 watt station that's a big ERI on one side, and then the other leg, you've got a JamPro antenna, and the third leg, you've got one of our Shively antennas, you know, in 10 or 8 bays. And I can't even imagine what it would look like if you tried to do a fly around or see what the patterns and what they're actually doing. They must be fighting with each other horribly.
They all have filters to prevent intermod problems.
Some of them may, but sometimes it's, that's how it is in some of these places, though. Some of these other countries, they just sit there. Whoever's got the most money for that, maybe they have Nautel transmitters. I'm not sure. They just dial it up to 11 and off they go. So.
When you see some of these countries, you mean like Iowa?
No.
A 16 bay and a 10 bay, just like that on the same town.
Yeah, but it's amazing that how the things even, I mean, you wonder how much they could be doing better for their station if they weren't mounting them this way, if somebody had actually taken the time to do it differently and separate them, give you your 5 or 10 foot separation and get a decent signal going out. So top mount is basically self-explanatory. This is what I was talking about earlier. I do have the picture. This is what we call a Lindenblad. And it's basically 4 dipoles around. This is a 3 bay down in Brazil, and it's a branch-fed system. So each level here, and then it's giving you that huge, full omnidirectional pattern. There's nothing touching it. It's just doing its thing. And because of that one's Lindenblad, we call it. Yeah. We've got a few of them, and we've actually got some in areas that have snow and ice. There's no radome that we have made to cover this type of thing. They perform well because it's a broadband antenna, so it's got enough give in it for the VisWire and such. And when it does ice up, it doesn't, you know, it's not shutting your transmitters off and stuff. It has some flexibility to handle a little bit of snow and ice. I wouldn't probably put one at 17,000 feet somewhere, but it's we've got some.
Plastic barrel down
there. Yeah, yeah. That's I'm trying to remember what the diameter across, but it's over. It's well over 6 feet across. Yeah.
That'd have to be a big ass pocket.
Yeah. This is another one. When I was with Dielectric, we came up with this in California. It's silly looking, but they had specific parameters. This is California, and nobody wants to see an antenna in California. They don't want to know that it's an antenna.
That's a flagpole top.
What's that?
That's a flagpole top.
That's what actually where we got this. Whoops, I kicked it out again here. I went the wrong way. Pardon. There we go. So this was designed and made by a flagpole manufacturer in New Jersey for us. Your feed line runs inside the pole going up to it. It's a 60-foot pole. I think it's 60 or 65. And then we designed this top mount. It's a DCRM top mount. I think it's 2 of these in the world. This is one of them. And but just for the fact, so when you look across the horizon, you really couldn't see much of it. They wanted to paint the bay a different color. As you can see, this is painted sky blue because California, with the pole painted, they've painted this 3 different times trying to find, the first that went out is stainless. And then they tried to do that because of the bay was. They figured it wouldn't be noticeable. Well, that was a little more noticeable, so they painted the pole blue. They wanted to paint the bay blue. We said, no, you can't paint the bay blue. So they left that as is. But from a distance. Yes.
Could have made a radome look like a cloud.
It could have. So it would be a cloud-based type. I get it. Yeah.
Cloud-based antenna.
But it was just for the fun of doing something different. This was a great project. And then the other end of this, his transmitter building is underground. You can't see, you look across this hillside, you see this, you barely see a pole, but you can't see much of the antenna from away. But everything else, it's like a bunker underground. There's a grate, and this grate has got a lock on it. You undo that, and then there's stairs that go down. Everything, it's a storage building underneath the ground. It's pretty crazy.
And they broadcast silence.
Well, it's California. You got to ask, what do you feel like having today? You know.
If it wasn't 100 feet off the end of the runway, it'd work out good, huh?
Yeah. But it's kind of a fun project to work on. Panel mounts. If I'd stop pushing the button, would be better off. This looks like it's just being held. It's being brought up and held in place, but this is mounted to the tower. This one is coming off of what they call a shiflerized leg, which is a angle leg with added plates to it and such on a taper. So you've got different length mounts holding this single panel out by itself. It's got a radome on it. Don't let anybody say they can't put a radome on a panel antenna for you. But the radome, but you've got that, and you've got an anti-rotation arm to keep it from swinging as well. But there are different ways to mount panels. And this could have this in one side, it could have another one just mounted flat on another side if you're trying to create some crazy directional pattern. But there are different ways that you can mount these and attach them to towers. This is the basic one. They lay flat on the structure. It's either across the two legs, it's just adapting. We've got some that'll have just, if you have vertical pipes, if it's a multi-bay, you just run vertical pipes. We put tabs on our panels, and you just bolt it right to it. It's actually a pretty simple thing. The hard part is running all of the feed lines and such going back into it for each antenna. A lot of the tower details, questions are pretty valid for us in order for any manufacturer to do their job correctly. Whoops, I get the stutter here going. Some installs are omnidirectional. People just want to slap something up onto a tower, and that's how they want to do it. It's going to be a leg mount. That's what they want. But a lot of places, they want to do a little bit different, a directional array. You have to have the information to be doing your pattern work and your final layouts. So these are kind of just running through a bunch of different things here. What's the leg size? What's your OD of that leg, or the dimensions if it's angle? You know, what are the different legs of your thing? Is it got extra, has it been modified? So your original tower had a certain leg size and now they've added to it and stiffened it up. We need to know that kind of structure because we're going to try to make something that's exactly like that to model.
First two line items are important too if you're going to somebody to quote coax, because
You need to know what to attach to.
member adapters
Exactly
or
right.
mounting components with coax.
Yep, exactly right. So
Last item there, is that much of a consideration of propagation?
on the guide,
Guidelines, yeah.
it does when we're laying out on a tower, absolutely. Because if you're coming down and you got an 8-bay antenna and you're going through where the guy line meets, and you're doing a directional pattern, that's, you know, nobody likes to run their antenna bays and have a guy line coming through it in the array.
But
Reflectors.
certain, it does reflect.
Yeah.
That's why,
Yeah.
that's why they make Philly string.
Absolutely. A lot of people replace that and they'll put a Philly strand length, 20-footers. Johnny balls, is that the name of it? They've used those in the past that supposedly get rid of some of that, but we try to stay away from it as much as we can. Some people have to do it just because that's the only place they have to do it, and you try to get as, you know, your mounting would be as keeping you as far away from that guy line as possible. So
Are there certain face widths that tend to distort patterns more than others? I've heard like a 60-inch face to tower is difficult to deal with.
we really seem to hate 41-inch, 42. I mean, there's some towers out there that have been that side. They're ornery, and it's hard to get. You know, you have to either get way off. 60 inches, another one that can. But there's just, you can always find a way around it. It just depends what you're trying to do. You either offset a pole or you know, that's really the way. Get away from the structure. If there's any way that you can get away from the structure, it's going to give you a little more leniency in what your pattern's going to turn into. Getting back to this, is it a round or angle material? Anything else in the aperture? Is there a ladder that goes up that side? Are there line runs? Do you have a wall of 7/8 lines on one side of the tower? We'd need to know that just to model it so we can see, because that's going to affect what you have going on. There's 1,000 other things. Your leg orientation, that's very important. Every time we see a tower report come to us, it tells you what the members are. It tells you where everything is on the tower. It tells you your loads on each structure and all that. Nobody ever prints a report that tells you what the leg orientation, and they were at the site, and maybe they're not surveyors, so they don't think they need to do that. But to us, that's one of the most important things. If we don't know what any of the legs are facing based on true north, you could sit there and do pattern work all day long, but if you don't have that orientation correct, you're never going to be able to put it back and get it lined up exactly what you want. So if the tower's tapered, you know, as a tapered tower, our mounts would have to be tapered. We've done some that way, so each mount is a different length, or you outrig a pole to make it so you get a plumb line to mount something on. Diameter amount of pole, a lot of those are a chain mount around a monopole. That's how you do that, but again, those are tapered. So you have to figure out what the gap is, the differences are between levels and the offset is. Come on. Get a function problem here. There we go. This is basically one of the things that we get. This is from Sabre. This one actually does have a picture of the orientation, which is very odd. But on the side panel here, it's going to tell you your leg diameters, it's going to tell you the horizontals, it's going to tell you your bracing, and those dimensions. Those are all the things that we really look to have as well. It tells you where your guy lines meet, and usually we'll say what kind of a structure it has where those guy lines do tie in. On a station side, you really need to know your city of license and what you're required to meet. So if whatever you're registered for that, you have to cover that by a certain DBU code. That's something we need to know ahead of time. Your population coverage needs, where do you see your market? So if you know who your market wants to be and you're still covering all these other things, maybe that pattern can be adjusted. So yes, it meets your 85% of the rule, but also meets a certain area that you want to cover as well. It's not just slapping it up there, but you can tailor it to be cover your city license and still meet everything else, but also hit the market, the target market that you're trying to get to. Just some basic things. You guys know all about this. What's ERP? Effective radiated power. That's what your power is rated from the FCC. That's your total. ERP is your TPO, which is your total transmitter power output times your antenna gain. Antenna gain, it's a reference number combining your antenna's directivity and electrical efficiency. It's how well it's converting the power into radio waves, basically, is what you're coming down with here. Basic chart here for your basic antennas that we have, side mounts, full wave antennas, power gain of 1 bay is 0.46, 2 bay is 0.99, then you get your chart for your half wave. They're consistent across the market. The only way you get difference is you're going to have different style antennas, a horizontal, a vertical, slant polarized. Those are all going to have their own gain structures to them. Antenna gain here. Directional gain is your azimuth pattern gain multiplied by your elevation pattern gain. So you need to have a couple other factors here to calculate what your total gain is going to be. And that's what you would file and with your proof for the FCC. Example on this goes back to that pattern. This is the composite pattern between the two, horizontal and your vertical. And when it gives you this information when we calculate this pattern, here's your vertical RMS, your horizontal RMS. What you need to be, the directional 85%, you have to be 50.27%. The composite RMS comes in at 50.531, so that's meeting your 85% rule. It's actually more than 85, but it's meeting that 85%. For this type of an antenna, how it came in is log periodic, so it has a horizontal azimuth gain of 5.588, which is rather high. To get to your azimuth gain, you take your horizontal RMS, you square it, and then take the inverse. So based on that other pattern we saw, 423 times 423 equals this number, and you take the inverse of it, comes to that 5.588. When you take that information, so you take your azimuth gain, multiply that times your elevation gain. So you're going to add everything. It can vary. On some of these, they have to vary it between your H and your V on depending on what the antenna is. But for this cause, your 5.588 times 1.15, because it was a 2-bay or 2-level full wave log periodic antenna at a slant, the power gain is going to be equal to 6.4. So that would be the total gain that we have for that type of a pattern. Excuse me. TPO. Transmitter power output, what's needed to calculate your TPO. Excuse me again. This is a basic chart or result of what we show, but the major points on this, you got to know what your power gain is for your antenna. You got to know what your ERP is. And then this helps you to calculate your line losses. As you go down through here, but for this system, 2.5 kilowatt, you're going to need 1.32 kilowatts for the 2.5. Hold on a minute. There's many different ways to bend the tubing and deform your antennas. We've been doing some retunable antennas. Is the latest thing we're doing. So you can get an antenna and start it and come out to you as a single frequency. But it has the ability to be retuned down the road, as opposed to in the past we've always done single frequency antennas or broadband antennas. Now there's some leniency out there, and that's part of what we're looking at to meet customer needs as opposed to just meeting what we think people need. So, but we need to be listening and see where the market's going. 6 years ago, we found ourselves with a large mix of fixed antennas, stuff we've been doing for 20 some odd years, the same designs over and over. And the market was tailing off a little bit. People were looking at different things, translators coming up, a lot of different iterations. Over that last 6 years, we have spent the time to research and do some R&D and to come up with some different designs based on what we're seeing. So we have 6 or 7 new antennas that we've come out with just in that period of time, trying to meet those needs. Doesn't mean every R&D project is going to turn into a full marketable antenna, but some of them are specific to one site, but some of them have played out very well. And some of these retunable antennas, excuse me, have turned into very positive antennas. They work well, they're inexpensive, and it's easy for us to offer that to customers to meet their needs. So, broadband multi-station capabilities. There's a couple of different versions of that. There's the low viswar pressurized style, or a panel antenna, or that type of thing, which is what people used to look for. Now people are looking for broadband antennas to put multiple translators on, to do different work like that. So you can have 4 or 5 different antennas feeding into that one broadband antenna, combiner network, dumping into that. Makes for a nice system for us. We've done quite a few of these. Quick ship antennas is another one that we're looking at, and that's something that somebody wants because they're not spending the time. They don't have engineering, they don't have consultants. They need something to get on the air, and they need to have it fairly soon. So we're trying to stock some stuff or have it within a week turnaround. And then the parts that we have to make are the interbay cables, but the bays are structurally there. They just have to be assembled and tuned. So, and then people keep talking about an off-the-shelf pattern. There's really not much of an off-the-shelf pattern. Each tower iteration is going to cause a different variation with frequency on an antenna. We do have some. A log periodic is basically simple. It's going to do the same type of thing. We have a couple other ones that we may call an off-the-shelf, but they still have slight iterations. And you'll see that there's some people that say, well, you can just take this pattern and file with it, and off you go. But they're not looking at towers. They're not looking at anything else except for one frequency. I'm going to touch a little bit here on the antenna planning, and with HFS and different computer programs and how they can work and help us to design antennas instead of doing it the old school way. In this example, we're looking for a 2-frequency solution for best tuning with one of our, what we call a Versatune antenna, and to have minimal visual. The components that have to be put into this, each one of them, if you're computing this on a system, you have to build your tower. It has to be precise, just like anything that you would be doing as a model for pattern. So the guys do that, and they build the tower out as it is. They have if it's an offset pole mount, they have to include that offset pole. They have to build the antenna bays. This one happened to have radome, so the whole bay is within here, and then the radome, everything is equal as it should be. And then you've got your two different bays. This shows a little better example of the detail that goes into it, but you can see all the different components of that antenna. And a lot of this from our CAD systems can dump directly into these programs. So you can take all the CAD designs, everything's dimensionally correct, and then put it right into the HFSS. Your power divider, this shows your basic design of a two-way power divider. This information, how this is designed and the lengths and all that stuff, still would go into that HFSS program. In the old days, we used to take all of those details and we put them into another program, which was called ADS. And this would help you to do the mathematical solutions. The HFS programs now allow you to do that all at once. So just as a quick example, this shows a bunch of information that's hard to say. There's different lengths, cables, and the different parameters. But going through these parts here, these are your two bays. And that's how that, that's the information that's tucked into that file for that. Then you've got your cable lengths for your two bay power dividers. And then your power divider is back here. And what you're trying to do, from here down, this is where you want to create your solution to get the correct ohmage and line lengths to do basically make this work with two frequencies and find your happy spot for your tuning slugs. Some of the things that they're working with on this, you've got different lengths, basically A through D are your calculation points. And then the standard cable length is 120. So this is helping you determine what your slug is going to be. This is the first printouts on it as just first tested without any more iterations going. But your sweep here, it's at a bigger scale, so it's hard to tell, but this is looking at 88 to 108. But on this scale, you can see down here, 93, 5-ish. It's got a pretty good visual response here. Over here at 95.5, it looks very nice too. 103, this one's like a 107. But up here in the center, you're at like a 1.4 to 1, way out of range. But by doing a couple of different mathings within this program, it makes it much simpler. This is the next iteration, looking at it. Just changing a couple of points. You're changing your impedance on each one of these places, and then they're fiddling a little bit with your slug sizes. But you've already brought it down to less than a 1.25, where it was a 1.4 before. These have changed a little bit too, so you're still going to find your best location for the broadband capability of this. When they came down to a final, it was like a 1.3 to finalize that. Basic H and V, when they're coming out in these patterns, that's what they're going to look like. On this one, I believe your blue these are opposite, but your blue on this one is your vertical, and the horizontal is red in this iteration. When you get into this is within the HFSS program, but this is giving you a 3D look at, a 3D version looking at the pattern. This is what the two-bay elevation pattern looks like. So you got your main lobe, and you got your separate lobes here. And this, if you flopped it on its side, that's what you'd be looking at, or if you were looking across this would be painting off your tower, pointing off, given your array. This gives you a slide shot with a chunk taken out of it so you can see your upper and lower lobes and your main lobe feeding out. And as you see, your pattern here, the composite of this together, the H and the V, I've broken it out. That's what this pattern here is. And so it's showing all your energy is going towards the front, and it has the tail of the horizontal there. That again was the tube A. This is just your horizontal by itself. You've got power out here, power in the back. And that's just strictly the vertical and how that showed on that pattern. There was nothing really going off the back side of it. And you can see that back here. These are just a bunch of the tools. Again, I'm not the engineer. I watch these. These things amaze me and what they can do and how they can change and how they can adapt. When we're coming up with new designs, part of how they're making it happen is basically with a computer instead of going the old iteration way. And it's quicker once you have the components in the system, but you still have to put the information in the system to be able to create these new designs and the new theories behind them. Nobody's come up with any brilliant new idea on an antenna in 70 years, probably. They're all basically the same antenna information that started from back in the pre-RCA days and all those guys. You know, that theory has all been continued. Different looks of them, different iterations. You bend the steel differently. We can make some different things, but it's all the same basic theory on how they're created. I was supposed to have a little filter here for show and tell to show you what the inside of it was. I apologize. It shipped in after I came out here. So basically, you're on any filter, your probes are what adjust your frequency. Oops. On the high power, it's the exact same way. The probes are the frequency. These are the couplers. On the little small 6-inch filter, which I brought here, you have DIN inputs and outputs on it. Those have little couplers, and all it is on those couplers, the closer they are to the wall as they rotate around, that's what helping you adjust it so your frequency's in, so you get your pass frequency, and then your reject frequencies, you can adjust those. And if there is a feedback loop, which we use if they're less than 2 megahertz stations away from each other, that has its own shorter coupler, so you can feed from one to the other and adjust those as well to protect against each other. I wish I had that unit here because it was kind of a cool cutaway to see exactly what was going on with it. Of course, the bigger filters like this, these are just made for more power handling. You know, we make a 4-inch round, which we use for a lot of low power stuff. Those will handle 650 watts. One of these, the bigger ones here, those will handle 30 kilowatts or more if you have blowers or other air movement across it. Installation on systems. Some of the biggest things that we run into when we ship a product is that getting it inspected once you get it to site. If there's damage or anything like that, you have to say something and you have to look at it right away to know if there's any damage. We get a bunch of phone calls, your antenna doesn't work or your filter doesn't work and I want a new one or something like that. They're wondering why. And as you go through the iterations, you start talking to them a little bit. You say, well what are you saying? What are you seeing? You know, we know that the things were tuned to factory because we have the printout and the data that says that we send out with it that it was tuned at. And so we get it and you continue the conversation. Then you find out, well, the box was a little scratched up when we got it. And then so you say, well, what kind of damage? Well, and then they send a picture of it and the whole end of the box is stove in. And then you start getting to the nitty gritty of it. It said, is there a chance that the filter was damaged at the same time? And then they take a picture of that and you may see a dent in the copper end of the thing. Or we put blue, I forget, it's a safety seal on all the connectors where the probe slides down and then on all the connectors so we can see if somebody's changed any of the settings on it. A lot of times that stuff's missing or it's chipped away, the blue seal stuff. So we can find it. We're not trying to point the finger and say that the customer is wrong, but we're just trying to find out why that they're having troubles with it. So we try to look at it in a couple of different ways. So we just want them to review packaging, look for any damage that came in. If a package has damage, tell the trucking company to document it and let us know. Review materials, post unpacking, look for physical damage, even if it didn't show up when you got it. If you see something that's wrong, let us know ahead of time instead of it waiting for it to be a problem down the road. And the other part of it, be prepared to store your equipment during inclement weather. Don't unpack it all and then leave it out in the rain, because it's not going to be pretty when you go to put it up. Here's a package that showed up that they had taken. I mean, this box is hammered. It looks like it's been around the country twice. And this is what was inside of it. And we pack it with foam, separators and all that type of stuff. It's a heavy wall, but these, some of these guys, the forklift drivers, we've seen them punch right through 3-inch line on the side. Yeah. And they can we fix it or use it this way? I'm sure you can do whatever you want, but it's not gonna be right.
A couple whacks with a ball peen hammer.
Yeah. We went through this earlier with the tower crew. Qualified installers. Make sure that your rigger crew is knowledgeable, and most people in the business know some part of it. Are they insured? That's a nice question to ask. Get references. Call Nate. Look at their website. See what kind of information you can gather, so you're making the right decision. Be certain that the tower is prepared for any installation. Has it been inspected by somebody to know that it's solid? This is a fault we found. That we had one crew that was telling us that there was nothing wrong with the installation. They had put it together 100%. What's that?
You got one of the patented split bullets out.
That's it. And it ended up, we ended up having to hire a second crew to go take a look and find out why that they're having such a problem at this site. And this is just one of the pieces that they found that on the thing, the split bullet. I mean, it's causing a huge. But it's what you get and what you're paying for these crews. It's well worth it to have somebody that's a good quality group doing it, not Tommy Bob and his brother that they get a truck and a ladder and off they go type thing. So review packing list before the start of an install. Look at your installation drawings and verify that you've got everything, rather than wait till after you get halfway there and you get a crew on the tower and they're saying, hey, we're missing something. That's a bad thing. Again, going back to the outside equipment and such, this is a basic thing that we have for installation drawing. Has your bill of material on it, shows your layout, shows your mounts, how they're supposed to be on there. This is an older one, but it tells you your base spacing over here. A lot of that information is right there if you have a drawing in hand to look at it. This is what can happen at a site if things aren't, in between. If you had a bad weather thing that you had to leave the site, this is what happened when stuff was just barely tied off on the tower and they were going to come back to work on it. These two panels came down off the tower. That is an outhouse. It's full of stuff at the time. I'm not sure what was going on there, but it's it's also with storage capacity.
Really crappy.
That's it. Yeah. Yeah. Why'd your stuff all bent? Whoops, I skipped there one. Thieves, we talked about that earlier. They love to steal everything, but especially copper, shiny things. So, best practices. Some antennas are DC grounded. Ours are, and they ground directly to the tower. That means you got to have a clean place on the tower. Don't leave it on the paint, and don't bolt your mount to the paint. Strip the paint off and bolt directly to that. You're going to get a good solid ground. ERI and other companies use a shorting stub, which helps get there. They're not DC grounded, but they use a different way to get about that. RF environments are not the same here. A busy tower site can have all sorts of RF energy going on. So it can affect cables and other things. So if you're in a high RF field, we've seen it so that some of the cabling on panel antennas or cable-fed antennas, branch-fed, are getting burned by other things that are there. There's other towers up there. There's higher powered systems that can be causing those issues. Purge your air line and your original line to get rid of moisture. We have purge valves. Pump it through, blow as much moisture out of it as you can when you're on site before you sign off it and turn it on. A lot of post-damage repairs, which we find that people are doing repair work on them, if they've taken on moisture, they've got water in them, you may need to do a vacuum dry down to get a lot of the moisture out of the complete system, which a lot of people don't use. It was more of a TV thing that those guys did that a lot more. They'd put a vacuum pump and pump it down before they'd fire up. Follow your manufacturer's information. Don't haul more than one antenna bay up at a time. You know, a lot of people, we've seen that. You send a picture, they get 3 bays all bolted together on the feed line. It's copper line. It's not a metal steel structural member, but that's how they're hauling some of this stuff up. This one, it's a nice clean. Yeah, you get a bag of tools on there. There's nothing wrong with that. But you get your antenna bay, your mounts there, and they're hauling it up singularly. Here again, they're doing the separate components. Installation again, grounding, strip your paint, use appropriate standoffs for flex line attachments. A lot of people we've seen use wire ties, different type of things. If it's smaller line, that's okay, but it's not okay if you're using 1 5/8 flexible line into, between things. Use the correct type of attachments. That's what they make them. They go around it, they clamp on, they can bolt. You can attach 2 different things together that way. It's a much more solid construction.
But I thought the black zip ties were UV resistant.
Well, they are, but ground your transmission lines, clean the installation so there's nothing loose hanging. We've seen some other sites that we'll look at. The guy says, well, I want you to look at my antenna. I'm seeing some troubles with it. And we had a burnout and something like that. And you see there's, in one of the pictures, there's a wire loose that's been in different pictures just flying, is not attached to anything. And you wonder, gee, I wonder if that maybe is what caused his burn through, because that thing had been flying around and laid across the arm. And in fact, that's what it was. It laid across the arms of one of the antennas for a while and basically seized right through it from the RF. So insulation may be better than grounding in some cases. We just had a site that uses a basic flex line type clamp on it. And they were having such a high RF that it was starting to burn the jacketing on the flex line. So we changed and went to a different route, and now it's got a rubber insulator that goes around the line inside of a clamp. We've changed the size of the clamp on it. It's totally fixed the situation, but he had such a high RF going on elsewhere that was causing him issues. Don't over torque your flange hardware or any other things. There's certain specs on your torquing. Follow that as much as you can. There's a lot of times that people go up on a tower, they see we use these little pop-off valves and they stick out the top of the antennas on the feed line, and they see it sticking out, there's a couple of threads, and they say, oh, I got to tighten that down. I got a wrench in my pocket to do that. But you just put it at a certain torque, because if you overdo that, then you open it and you crush the part of it so it will no longer pop off on the valve. This layout here, it looks nice and clean the way it is. I don't know if you can tell here, though. This is a tie wrap over here, though, as opposed to something that's solid and fixed, keeping it away. This is tucked in behind the power divider, not attached to anything, but it's just kind of laying in behind there. Those could be problems for friction sites going down further down. So this one here uses a bunch of different iterations. This is a back-to-back clamps. That's a good solid way to do it. This uses your angle adapters with a regular flex line connector. This uses yet another style. So this is fairly well tied off. So there's not going to be a lot of movement, a lot of friction, a lot of issues you're going to see down the road on that.
Dale, I saw a picture like that one time where where the lines were crossing, they had recommended that you take the insulation off and bond the 2 cables together to keep down so much RF back behind the panels. Is that something you recommend doing?
We've tried it both ways. And we've gone back to using certain connectors and that type of thing. We've tried to do that, and when I was with Dielectric, they did a lot of that, trying to ground everything to each other. Right. In some cases it worked, but in some cases it was more of you were getting more damage while they're stripping those sections to get it down to the bare to get a connection there. It depends on your RF field and what you're dealing with. So I think certain applications do it and certain don't, and it's a very hard thing to figure out which is going to be the way, which is the smartest way to go. So with any of these connectors, a standard rule, if you're using 3-inch flex line, every 5 feet you should have a standard hanger. If it's 1 5/8, it should be every 3 feet, just to keep the movement down and to control what's going on with it. Don't rush your installs. Document everything with pictures. John, is it, with your tower crew, is it John?
Yes.
Do you guys take pictures as you do in your installation or when you're done a complete?
You know, it depends on the job, but
Yeah.
yes, that's the best practice.
Yeah. It helps us as manufacturers too, because you can see, hey, this thing was installed properly. So now you can sit there, that's not, if you get a phone call down the road, that's not a problem. What are we looking at now? And it's a great tool for us, but I just didn't know if it's a general thing that you guys do all the time. Get a report when you're done, and then make a final reports for your tuning or Viswar sweep, so you have that information going forward as well. Have everything, so when your site's done, turned on, you have everything as a starting point to see what's going on down the road if you need it. Also, a visual exam from the ground. We've had pictures come in that people take it, and you see the bays are all over the place. They're not in a straight line on an off-rig pipe. And you wonder, I mean, to me, it's common sense. You just, you could run a plumb line or whatever, and you could find out where all your bays, to at least line them up. But there's some sites that don't use that. This one is not one of those. This was made to be that way. So you've got 4 bays going one way, 4 bays, these other 2 facing the 2 totally different directions. But it's certainly a way to keep things lined up. Same thing on this. You've got a pole here. Everything is in alignment going up and down. And that's what they need to be. See if I run through some of this. We recommend a yearly inspection. Have somebody go up, check your flanges, make sure your hardware is the same. If you see one that's loose and floppy, you get some troubles there. Or one side of the flanges are angled. Sometimes you can see a couple of years down the road, if they had pinched an O-ring, you can see the O-ring sticking out from the pressure being under it. Keep a log for pressure data. If you see changes in the amount of pressure that's in your line, if it's a pressurized system, if it's nitrogen or compressor dehydrator, keep track of it so you can see, is it humidity issues, is it whatever is causing that to change for your pressure. It should be fairly static across the board. You should be able to keep a consistent level on it. Foam line's a little tough because you're not putting pressure in it, and if you're not seeing any change in your pressure, you can be hiding issues you may be having up on the tower. So keep a log of your Viswar changes going forward. If you're having spikes, document them. So maybe you can determine what the weather conditions are at the time. Is it hot, cold, rainy, icy? The guy climbing on the tower. The antennas, you look at the visual looks at the bays for burns, hot spots, discolorations, wind whistling through it, the other things you can look for. But be certain of what's supposed to be there and what's not. And then that way, if you had a drawing, an install drawing right there in hand, you know what to look for ahead of time. You're going to see what the outlay is supposed to be, what angle they're supposed to be facing at, and that type of thing. Check your hardware, clamps, look for ice damage, climber damage. And I'm not picking on riggers here, I'm not, but we've seen some cell guys that have done some crazies that use the ladder, some of our antennas as ladders while they're trying to climb up to get to other things. They step right on these things while they're, some of them have been under power, so I don't understand where these guys are coming from at all. A digital camera for documentation. And then, like I said before, have a baseline set of readings for your system pre-storm. There's no such thing with an antenna. You just go put it up once, set it and forget it. Isn't that the commercial that the guy sits there and he's cooking stuff or whatever? But you don't just put it up there once and never check on it again. This had been festering for quite a while to create that kind of soot. But if you didn't have anything in place that's telling you, or you notice, or you're checking on it, what the changes are, nobody's monitoring your Viswar, nobody's checking to see if you've lost pressurization or something. This type of stuff, and this is it. Things above this are really cooked. So if you had things, you could have monitoring systems. There's basic things you can look for, but at least keep an eye on it to see what's going on. So here's another one. This started off as somebody had done a basic crimp. He bent it a little too tight, and that's what happens after a period of time. This bay was kind of funny. One of our guys wrote a note on it. He says, if I told you once, I told you 1,000 times, don't put 50 kilowatts into a single bay. But this thing got smoked, and the guy, the guy finally admitted that he had been running too much power into it. He thought that he could get away with just a little more than what it was rated for. So it wasn't 50K, but he.
You guys built the headroom in, right?
Yeah, what is it? You can't plan for stupid, right? Yeah. Rules for maintenance: keep your transmitter site clean and accessible. Have a record of your readings, antenna, and the filter from past visits. Have install drawings on file for reference. Ask your manufacturer to supply you with them if you don't have them. If you have a new engineer on site, can't find on the old records, call us. A lot of times we can pull up some stuff and get you the original test data and install drawings. Every site visit, if you have somebody plan on it and do it regularly, just look at the antenna. If you see stuff hanging off, then you get some issues. But make sure that it's a regular basis that you're doing that. If you know somebody that has a network analyzer you can use or rent or have available, that's a great tool to have. It helps us to help define some problems. If you don't have that, and rather than pay us to come out and do field service, if you have somebody that can get the equipment and use it or pay a small amount to do it. If there's tower issues with movement of tower, when was it checked? When were the guidelines adjusted? We've had some stuff that, they're seeing an amount of feet that the tower's moving. We project on our antennas, we ask for, I think it's a ½ inch movement per 10 foot or something like that. That's a maximum we want to see. There's things that are moving a foot in the swaying in the breeze, and that's, if you're on a rigid line antenna, that's going to damage everything going up through there at some point in time. When is it time to replace your antenna system? If you've had multiple lightning hits on the antenna and you keep patching it and fixing it, is usually damage that you're not finding, and over time, that's going to become more and more of a costly problem going forward. Have you got any lightning protection in place? Has the ground issues been fixed that that are causing some of these issues? Because a lot of times, if you have lightning and you're something that's a DC grounded antenna, it should feed right into the tower, go right to the ground, and go away. You shouldn't be able to see or have that much damage on them. Long-term under power without the system being pressurized. When we have a pressurized antenna, they expect it's going to be there and it's going to keep it clean, it's going to keep moisture out of it, all those things. If it's been, your compressor dehydrator hasn't been working for months and there's moisture allowed in it, that's a problem that's going to cause other issues down the road. Moisture inside there is going to degrade your copper, it's going to cause all sorts of a mess. So the aging process. We all have this issue. We're none of us are totally young, except there's a couple of young guys out back there, but not so much, the rest of us. But nobody wants to be taken out of service, but you still got to maintain stuff, and you got to look at, we still get phone calls on 40-year-old antennas that people are asking us to provide parts for. And we still do in some cases, but to do that nowadays, when you don't maintain parts, it's hard to do. How long is too long to maintain it? It's not like a classic car that it's going to increase in value, so you have all these guys that are supplying parts for these old cars. A lot of it, you pay a lot more for those single parts to be maintained for a 30 or 40-year-old antenna. At what cost are you paying, though? Because we're doing them one-off. We don't stock anything. It's been obsolete. We can create it, but we're having to do 1 or 2 pieces of this thing, and it's costing a lot more money for us to have our machining. If we do it in-house, we pay somebody to do it. One or 2 offset parts, it's very expensive to have manufactured that way. So a cost reason, it makes it hard to maintain. Something like this, we seem to get every now and then. We send somebody will send us a picture of this is what the antenna looked like on the tower. Very damaged. We'd sit there. There's no fixing a bay like this. We're going to either make your new bay, or if you have multiple bays like this, it's time to think about, by the time you add your costs up, which is going to be the best way to do it. If you've had ice damage from a TV tower shedding, TV antenna, or whatever, this one I think was actually damaged. Somebody was taking another piece of equipment down off and they get tangled up. So there's planned obsolescence. Some companies actually set a time frame. They expect their antenna to last this long, have a budget to replace it over a period of time. I don't think that happens anymore. It used to be something that people would plan for that stuff. 20 years they plan on putting up a new antenna or something, or less. You're changing demographics. You've got a new tower site you either have to move to or you want to move to. It's a better location. That's an opportunity to replace your antenna if it's, 15, 20 years old and you've had some issues with it. You have a new market or population center. Now you've got a new area you want to cover. You may want to go to a directional antenna. There's another opportunity to replace your antenna. If you have a chance to go on or have a tower space that you want to put up a multi-station antenna, there's another opportunity there. We've had some that the tower structures are unsafe to climb, and it's safer to drop the whole tower, antennas and everything on it. Nobody wants to go up it, and they find a way that they're going to drop the whole thing to the ground and then start from fresh. This one, it did it on its own. It's one of the things that something gets tangled in the guy lines and the whole tower, but I mean, that's a twisted mess of what's ended up on the ground. And that antenna was put up, I think it was 6 months before this. So it's a brand new, it was a 10-bay antenna that had just been put up, came down in a pile of mess with the tower. I think that was because the people that were doing the tower, they wanted to save money and not hire a qualified crew, and they did it themselves or something, which I don't even know if you're allowed to do that, but I guess they did. So, also, if something comes back to the factory, just shipping it back to us, stuff gets damaged. This antenna bay, it'll get bent and twisted. We were able to fix it and straighten it, unsolder everything, and straighten things out and put it back together. But then you're touching it twice, as opposed to buying and building a new bay. Now you've taken it apart, fixed it, put it back together. The actual cost involved in it, sometimes that's an unplanned thing, but it still can be a factor in what we're looking at. So that's what I've got for you folks.